Hello everybody, welcome to another stream. How's it going? So this stream we're going to be carrying on with the entity code generator because last stream we actually started generating some code. And now that we've got the getters and setters, code gen, the archetype, ID, references and structures, and property enum all being code gen, and all the function prototypes that we need. It's now to try and do all the sort of internal stuff. So this won't be code gen. We need to make an entity record pool, and then we'll probably do the deferred delete, which will need to be code gen, and entity create, which will be code gen as well. So let's get started on that. So if you guys know about the entity record pool, it's basically like the way that our system works is that our entities, we do not have direct references to those between frames. So we need a way to get a reference to it, and that's stored in the record. So this record pool, which is just going to be a pool allocated set of records. So whenever you make an entity, you create a record for it, and you get an ID back. So essentially, it's a special pool where so it's going to be just like our object pool, that core object pool that you've probably seen in the code base. Right, I thought I saw the word factory come up. I was like, I don't have a factory in my code base. But yeah, it's like the object pool that we already have in the code base. It's just more specialized to this use case. So we're going to go ahead and design the API for it quick. So basically we need an ent record pool in it. And it just takes in a record pool, initializes the thing. I don't think we're ever going to want to destroy it or deinitialize it, because ain't nobody got time for that. But we are going to want to allocate a new slot. So that will give us back probably an ent. Wait, how do we usually do it? Do we usually give back? Let's see the object pool for a minute. So this is the object pool, the sort of generic one. When you call alloc, it gives back the pointer. And the ID comes back via a pointer. Alright. So we'll do the same thing. So again, ent record, back via a pointer. And then for another pointer, you get back an ent ID. So then you do want to be able to deallocate a record right when the entity gets destroyed. And this one is just going to take in a ID by value. And what else is there? We don't need iteration. We don't need to get an ID from a pointer or get an ID from a pointer. So all these functions exist because it's a general pool, and it allows you to allocate at a particular. You can say, hey, I want this ID or this index to be allocated. So it means you can sync it across servers and things if you wanted. So. Or you can serialize and deserialize the whole pool, which means you have to structure the pool in a slightly different way. It's only very slightly when you add features like that. And the iteration thing is going to be slow, but it's there just for debugging. It's kind of nice for that. But yeah, so we don't need any of that in this specialized pool, so we're just going to go ahead and implement these three functions basically. And that should be good. So I think we've got to say entity.c. Oh, this is the docs one. Whoops. My brain was like getting confused. This was the example that I did a few days ago. A week and a bit ago. So we should probably delete that file. Close. Right, let me just nuke that into orbit. I'll nuke that from orbit, I mean to say. Where are we going? Docs, entity, yeah, that was just the... There we go. So, yeah, let's go to the actual source file. There we go, logic entity C. So in here we can go ahead and plop this in. So I should really do one of those section headers. I like me a good section header, and I've not really been doing them. Yeah, how's everyone doing? Hope everyone's doing good. Hope everyone's having a good weekend. Okay. So with this one, it's the record pool. I guess make another section quick for archetype and drop that one in there. Move this other one in there. So I need to figure out my sections. Right, so this one... So let's hop back to the... Yeah, perfect. So I think we just want to like allocate this array. How do we do it in the object pool? Isn't it using virtual memory? Is it directly? Oh no, it uses the right. Yeah, we should probably have the have a custom allocator. Passed in, to be honest. Drop one in there. Drop one in there like that. Hey, Fennec. Fennec Fox, new from orbit. Insight to violence violation. 20 social credits have been debited from your account. Oh no. Oh yeah, good old Kier. Yes. That man. He cannot escape the news. Yeah, I wonder how all the stuff is going on lately with him. You know, not really been keeping up with the news, to be fair. Has he done anything crazy lately? Right, custom allocator. So we alloc. Then we... Yeah, so I think we're just going to alloc an array, basically. They should all be zeroed. Well, I can maybe just zero it explicitly, but... It sits in global memory, so... Should be alright. Pool, records. allocate an array of type T, which is record. No align is needed, I think. Size is going to be something. So yeah, this is another thing we should have passed in. Be the number of elements. Cap. Cap. Just imprisoning the natives fit in and freeing extremists, the just usual. Yeah. Yeah. Very bizarre. Politics is a bizarre place at the moment. Yeah. Yeah, I typically stay out of the politic talk because, you know, it's not what people come here for. And, you know, it's pretty 50-50 environment at the moment. So you're just going to upset someone. MSTV, what hero would you be? I don't know. Not sure. Don't know, I just hope to maybe inspire some people. That's about it. You know, raise a good family. You know, basically inspire people, raise a good family. I think that's the type of hero I like to be. Where does it come from? Well, my full name starts with HE, and my last name. Yeah, the first name starts with HE. My last name starts with RO. Join them together and bam. Hero. So, yeah, if you check my Twitter out, you'll find my real name. So then, basically, I did have it as a more, you know, classic Twitch name where it's not very pronounceable, but it was a kind of a mishmash of my name. So people just took the start and said Hero. So I changed it to Hero Dev. I decided to just go kind of like, yeah, just call it Dev. That's right. But I think it's good. Raise a family, no, you're definitely going to jail. That's a good take. That's a good take. Yeah, I'm a family man now. I have a child. Get your Chad. Let's see what you did there. Hey, Cap Pain. How you doing, sir? Good to see you. Man, if I guys could tell you, I literally just took my boy out yesterday. I put him in the pram and went for a walk. And it was just fun. I was walking around, just seeing him happy, holding on. It just warmed up my heart walking him around. And I would never have thought I would experience something like that. And it's just hard to tell someone else who hasn't had a child. Like, that, yeah, it just probably sounds very weird hearing that. But, yeah, it's what I experience now. I'm happy about it. It's just really weird trying to tell someone things you experience and they haven't experienced it. Just, but yeah, it was really nice feeling. I'm just so happy to have my boy. Just such a great thing. Makes me smile. But yeah, that's the type of hero I'd like to be, I guess. There's the question answered. So, record pools. But yeah, I hope everyone's having a good weekend. What's people been up to? Tell me what you guys been doing. It's also bank holiday tomorrow. Anyone got any plans? So we've got this sort of free list thing. Right, so let's quickly just get the board out and just be like, what is a pool? Right? Very basic concept. You allocate a chunk of memory, right? And I'll basically let you guys in on a secret. It's a superset of an array, basically, right? You got an array, right? Here's our pool of 6 elements. We only want at most 6 elements. We allocate one, we allocate another, we allocate another one. Notice how we're bump allocating them. Right, then we're like, hang on a minute, I don't want this one anymore, so I'm going to free it. Boom, it's now free. And then later on down the line, you want to allocate another one. Boom, it's allocated again. Right, so it allows you to allocate and deallocate individual slots of an array. It's that simple. So at the start, we don't have a free list, so we just bump allocate. And when something gets deallocated, it goes in the free list. Do-do. And the free list is just a linked list for all the elements. So if this one gets freed, that one gets freed. There's a little bit of header, which it has like, hey, the pointer to the array is here. And then this one goes, hey, the count is 2. And this one goes, hey, the capacity is 6. And this one here goes, the free list head is this guy. And this one is like, the next one is this guy. And it's just that simple. That's all we're building. TLDR. Pools. Yeah, it's that simple. Why in life is easy all the time. So when we allocate, we go, hang on a minute. Is there a free list head? It's an index, right? All right, so we'll say U32 is, that is equal to, not equal to U32 max, aka -1. Then we go, right. So at the end of the day, well, we first take the, yeah, so I think ref would be, I think we'll make ref when it's a free slot. You know what? $15 bits is free. So I guess these two could go when it's optimized, but we need this next. This linked list of, oh, this needs to be U32 as well, doesn't it? Right, I might go to the other. Fine. Wait, delete queue. Yeah, why am I doing this? Right, get out of here. This delete queue thing. Right, so do U32 or U16 probably. An array of like counters. Counter and is free. Almost another strut. Slot. It's kind of like some slot thing. I don't know. It's gonna have like a U16 there for like counter. So we can check for use after freeze by comparing the counter. Then is free. So we can check if it's actually available. And then in non-debug builds, we can get rid of this whole array. They don't have to exist. Be pretty legit. Oh, damn it. Gotta type it out. Slots. So we can literally just, See, I don't really have like an if debug thing. Not gonna lie. Well, no, you would. I've already got it. I think it's if core. Hang on a minute. Enable debugger surgeons. It's quite long. Not gonna lie. That'd be pretty lit. So we can remove all the safety checks like a champ. And ready builds. I'm building an ETL pipeline right now. That's about it for my weekend. ETL pipeline. Yeah, what is an ETL pipeline? Extract, transform, load. Why do you load at the end? Is it like a database querying thing? Aha, yes. Right. Fair play. Sounds interesting. So this is this to do with how like are you building like a database engine of some kind, or is this sit on top of that? Anyway, enough pictures. Good evening, how's it going? Hey there, Devastated. Yeah. It's going good, man. It's going good. Just been chilling with the family. Yeah. Yes, chilling with the family. Yep, it's going alright. But yeah, not too much to be honest. It is my wife's birthday tomorrow. So I've got a set of things to do tomorrow. Hopefully she's gonna have a good day. Got something planned out. And she's not very good at she always wants to know surprises ahead of time. But I'm keeping this one a secret. Okay, that slot thing is pretty good. So basically, always in debug mode. Maybe we can change that name and shorten it at some point. But so you always grab look in the slots array, but no, we didn't allocate the slots array, damn it. Slot. Noise. So you grab a slot, an entity record, or an ent record slot. And then you use this address of pool slots, whatever this free list head index is. And this gets you the generation counter. We can pull it out of there. So we'll say, I'm going to say use 32 counter equals 0. And we'll simply just pull out slot counter like that. And then I guess we're going to assert as well that slot is free. Non-free slot. I guess that's got a word, it's called allocated. Allocated slot in free list. Sad face. Yep. And then basically you build yourself a lovely ID from this information. You go, right, I got myself an NID. And this thing is... Oh, you've not really made one of them yet, is it? do your int ID pull free list head index, and then the counter in the second part. So that'll squish it together into one 32-bit integer with the counter in the high bits. And then simply we shall return. See, I wonder if we should just return the ID here. So the final thing you want to do is you need to be able to update the free list head index to be whatever the next free one is. So if you go, we're going to store this ent ref, right, will be the next free index when in the free list. When record is in the free list, this field is the next free index. So we're just going to get ref. So you go and get record. And then when you probably just want to zero the item as well. I always like zeroing the things. Records, you got it. Then your next free index is equal to ref. Is it ref.raw, I think? I have a bit of a weird time remembering. Yeah, ref.raw. I've still got to fill in these defines, which we'll do in a bit. Let's just get this code in. Then afterwards, we might as well write back some memories here to zero it for a bit of safety reasons, I guess. Well, no, there's no point. Yes, I'll come back uninitialized. Oh, shoot. ID out equal ID. Then we return the reference to the record. Yep. Thank you. Joe's dead. Yeah, so this is the logic if it's inside the free list, right? We simply look at the free list head, get the slot, get the counter. This is in debug builds. So when we do, oh, we forgot to do a get function. What wally I am. We do a getter. Something like this, innit? But anyway, back to where we were. So we'll do that one obviously at the end. That'll get all the safety checks. Check if the counter is a match. So yep. Get this slot thing. That was a bit silly. Right. So read the counter bit into this local variable. Make sure that it is free, because if not, it's a bit weird. We've just tried to allocate from an allocated slot. Instantiate the ID. And then get the record that we're allocating. Pull out the next free index. Next free index is stored in the record ref when slot is free. And then we update the next list head. Yep. Cool. See, my concern is then this has probably got to be set to E32 max. Right. So then the other case is you have to bump allocate your slot. So basically, this could all be moved around a bit. So this would be the entity index. So just call it IDX. Or I call it index because I have something called ID already. And all this is going to do see, I wanted to get a bit of code sharing going, but I might just copy paste it. Because this needs to happen. Ah, this is good, this is good. Right. Let's move this out of there. For crying out loud. Yeah, right. This will stay in though. So if you have an element in the free list, you shall set index to this free list head index. And that's what you're going to allocate. Then we'll update the next free index on all that. Then if there's nothing in the free list, we're going to bump allocate. So count is going to be the next index. Then we bump count, and then we just make sure that we do some special kind of assertion. So that the array is going to resize from count to and whatever the capacity is. So make sure we don't overflow that capacity. Now bump allocate it. We can then go over all the slots given this index, so we can allocate from. Make sure it is free. It's all zeroed, yet. Oh, I don't know if it's zeroed, is it? Should explicit zero probably. We'll just assume it's all zeroed memory. Trying to allocate slot which is already allocated. And then this will be called index. And return the record. Where's the record gone? So we do need to take the address at least of it. And then return that like so. Right, so that's an allocate function from an object pool. It's pretty legit. Hey, Elwood J. Finley, welcome. How are you, sir? Right. Pretty good. So it should be nice and quick to allocate one of these guys, and in debug mode, it's in release builds, it's even quicker. You'll skip this check here and skip this check, but hopefully your code has already been tested a whole bunch, so that would never be a problem. Then to deallocate something, you add it to the free list. So first of all, you need to probably do a get. So the way I look at it is the get does the assurance that the ID is valid, and it returns to you the record pointer, even though it's very easy to do it, right? It's just an index. I get the index part and index into it. This is going to do the validation. So we'll get to the validation part in a bit. Let's just do the deallocation scheme. So the next thing we're going to have to do is we're going to take the record, we're going to take that reference, and we're going to store the current free list head index in there. So if this is the first one to go in there, it's going to get U32 max. So it's going to go into here. Then we're going to make this index. So we're going to get the index part. Well, okay. Then we're going to say free list head index equal int id. Do I call it? Hang on a minute. Where's the ID? You have to find it like this, innit? Yeah, we're gonna do a version like this. So this is my core define ID. This is the one I use for the object pools. But yeah, I'm running this specialized object pool for this this one. So we're going to get the first one that goes in is the ID and then counter, and then you want to be able to get the ID, so the index, IDX, and then counter. So you want to be able to extract those boys and girls out. So it should be as simple as ID index, put the ID in there, and right, then we're nearly there, right? The next thing would be to say pool count minus equal 1, and take away 1 from the number of elements in the actual pool. Do I want to do that? Probably not. Well, that means this would need to be done as well. You know what? Let's not decrement 1. It's just, so this should be named. Yes, it won't give you the number of elements in the actual pool then. Actually, we'll do it because then we can. It actually means count then. Let's move this out. Let's plop it here or something. Right, the music has decided to stop. Wonder where that jam was listened to last time. Was it this one? It was this one. This was such a good playlist. I'm going to enjoy this. Turn this one up a bit my end. Yeah, so this count thing is always going to tell us the number of entities that are actually allocated, right? So I think this is all we need, right? So we get the record, we update the record to point to the next item in the free list. We make this record the first one in the free list, and then we decrement the count. Oh, we need, in debug builds, we need to mark that it is free. So that's not really a lot of stuff that we do. It's quite interesting, right? So we get the free slot, which is going to be given to us via, hang on a minute, this guy. I could write the word index and then do the same thing as before, right? E32 index equal this thing. And then we get the slot. We then mark is free, slot is free equal true. And then we be on our way and carry on with the rest of the code outside this function. So now, doing the record pool get, this is where the validation goes on. So we need another one of these slot, if defs. So we pick up the slot, we get the index, and then we get the counter as well, the generation counter. And the whole idea is that we're going to be just making sure that it is what the slot says it is. So if someone was to free this slot in the array, like deallocate it, then we allocate again. Oh shoot, we didn't increment the slot. So when we deallocate, we need to increment the counter by 1. So when we deallocate, we increment it by 1. So when we get a new entity at this same slot, the counter would be different, making the ent ID be a very different number. So when we try and get with an old ID, the index would be the same, but the counter would be different, and this assertion will say, hang on a minute, that's an old ID. So it's a use after free. Use after free detected. Something like that, yeah, with a good old sad face. And then we return the address. You know, I like getting it beforehand for debugging reasons. Let's do that. Yeah, so let's just read over that, make sure it's all right. So we get the index, get the counter. We get the slot, make sure that the counter matches, and then we just return, point it to the record like they wanted. Nice. That's still nice and quick there. So I think we're in a good place. So this LSP has decided it's like it can't figure out that this. I don't know what's going on with this, to be honest. U16. Right, I've just not included. Yeah, I've not included some things. In this header file at the top. Like A. Include core. Oh, engine core. I've got an engine folder now. Even though I'm building a game without an engine. But that's cool. Yeah, so that's it, guys. The record pull is probably done now. So we can now move on to something else. This is going to be very useful. So I think, why don't we tidy up this file a bit? This is all the stuff that's not code generated. This is all the stuff that is just it's just the common things that are fixed and don't need to be code gen. So let me get some of those section headers in and just tidy this thing up and make it a bit neater. And we'll figure out, yeah, we might do the deferred delete thing, or deferred D init as I would call it. The entity creation, stuff like that. So this is, I guess, is to do with the properties. Properties. There's an archetypes one as well we can make. Archetypes. Then this is the entity reference. So I call this entities or entity. I could do one for its entity reference, and then I can move this to there like that. Comment for there. I have got sections for each of these for the typed in the code generated headers because they have typed handles and typed IDs, typed references. Yeah. So I guess we'll repeat it, even though it does add a bit of padding to things, but oh well. So yeah, let's finish these off. So how do we make one of these? So I reckon that we should put a static assert here. And we should say, hang on a minute. Wait, shoot, enter archetype. That'll be Codegen. Or this might have to move down after the code generated include. Right, okay. Yeah, so maybe we can't put it in here. We'll have to put it... I might put it in the code generator. Or should I stick it here? I'll put it at the bottom. So what we're trying to say is int archetype count. If that is more than... Let's say... So you could say 8 or 16, basically. Yeah, I want to say it's less than or equal to... If we say it's 8... yeah, because I don't know how many archetypes I'm going to have, but I don't want to have too many archetypes. This is the thing. So if I restrict it to 8 for now, I can always change it. Right. We have code. Right. Yeah, so I could just make this like way higher, like 32 or 64, and it'll be fine. But the reason why I'm putting it so low is that I really want to know. Like there's a reason why I don't have too many archetypes. Because we'll have a bunch of like small pools per region, and it'll just be wasteful. We won't even like fill up cache lines if we have too many archetypes. So I want to try and restrict that down and be aware that I'm adding too many. I could say 4, but I think I'm going to fill up 4. Or maybe not. Let's do 4. And just be aware of it. So we could say that we have more archetypes than we planned for. Make sure you adjust ent id, ent ref, and friends, and their typed friends. Before upping this number. Right, that's pretty nice. So hop back to here. That'd be pretty handy. Just make that a bit more. Oh, right. So that'll be there. So I think really I got to move this, unfortunately, underneath this include. Kind of sucks. Don't know where I'm going to stick it, to be honest, but in the code generated thing there. Right, the record pool, entity pool. Right, reference. I said sure, but I didn't write it. Damn it. It's my brain going ahead of my fingers, isn't it? With more types than we planned for. Make sure you adjust. And the typed friends before opening this number. Cool. Thank you so much, Asrenus. Appreciate it. I do that too much. Like I'll say a word or think it, and then I'll just end up skipping it. Entity record pool. Alright, so that's all that there. So we're going to include the generated stuff here. And I guess the next part is the iterator. So maybe I didn't need the word entity and all these things, but there we go. Iterator. And then I guess some of them could be some functions that require some of the Codegen stuff. But that being said, I could just declare them here. They won't. You can't forward declare enums in C because it could be signed or unsigned. You don't know what it is. So we could just make it untyped. These things untyped. Just make them like a plain old int and type def them. Yeah, then things could stay next to each other. So we could just say like, you know what, screw it, you know, type def e32 int prop, right, enum in, you know, maybe you just say u16, right, make it smaller. Enum in entity generated.h. And then we do the same thing for archetype as well. Archetype, it has to be already be u8. We're never more than that, no way. Yeah, I think we'll do that. It's just entity gens, that'd be so type def enum. Yeah, this is the me testing it out. So that's not, yeah, here they're on the code gen. We'll just nuke that. Right. Cool. So that's taken out the code gen now. And we'll just live with it being untyped. Since it's like my project, these untyped enums are not really a pitfall because I know the API, I know how to look out for them. But if you have like a bit of a wider project, it might be a bit, you wouldn't get like a compile time error if you pass just a number in to like functions or something with these. But yeah, it's not really a problem for me. I don't have these issues because it's my own code base. But it's just something to be aware about if you do something like that. Right, so these entity ref ones can now go here, and that in this section. And then this one that we copied down here can also go in this section at the top. Right, okay, that's good. I'm a mega beginner dev, but why is Node.js, TypeScript, React, Angular, Azure? Oh, take a breath. Nginx, Git, AWS, Blazor, Next.js, Flutter, Firebase, Riverpod, Docker. I simply do not understand. There are so many things. Yeah. Development is the wonderful thing about development is that there's so many options. There's so many different ways you could do things. There's so many different problems to solve. That's why you need different ways to do things. But a lot of those things that you listed, I would say, yeah, not all of them, but a lot of the things that you listed mostly just get in the way. And you should really try and understand some more of the fundamentals before using such things. Yeah. Because if not, you'll just be chasing the next hype in development. You'll be like, oh, this is the new cool thing, and then I'll just go and use this. Because all these guys are using it, but the fundamentals don't change. Right, how a computer works doesn't really change too much. Things get added, but the fundamentals typically stay the same. So I recommend learning things which are more translatable, can be applied to different disciplines. But yeah, that's just my two cents on the matter. Yes, we didn't fill these in. Start chasing around organizations. So nref, I think we'll just stick the archetype in the high bits. We're just got 4 archetypes for now, so we just use the top 2 bits. So we should be able to do the old archetype shift left 30, right for a 32-bit number, chuck them in the top 2 bits, all that entity index in there as well. Call it a day. Then when we want to pull out the archetype, we get the entity ref, or the entref as we call it here. We've got to say .raw actually, because I realize it's a structure. So hang on a minute. We should write about that. So these we have to go and wrap this in like a compound literal. Right, and we'll just do the old. Let's get a bit of spacing in there, right? Nice. So getting the entity index is going to be an entref.raw anded. Now bear in mind, you probably want to wrap this in brackets because this is a macro. And macros, people could put anything in there and it's just a copy paste of the code. It just appears and gets substituted there, and it can be quite dangerous. So wrapping stuff in parentheses is advised. Then we want to and a bunch of bits. So that's the maximum number of a unsigned int. So we want to use the top 2 bits. So that is, we're going to leave a 3 there. So 3 would mean in 4 bits, it's the lower 2 bits. That would be on, the upper 2 bits will come off. So it might be that way around for you guys. Whereas C would be the upper 2 bits. So C would be the other 2 bits that we just turned off. Hexadecimal. Oh yeah. Just double check that. 1, 2, 3, 4. Yep. Cool, so we're just basically going to do the same thing again for the ID. So with the ID, it's the other way around, isn't it? And I called it a damn ref. What the? All right. Right, so ID. All right. So we get an index. And a counter. So how many bits we can use for the counter? Well, we're going to use 50. We got 15 bits in the slot. But 15 bits of counter is quite a lot, and I think we actually need. I think we need a lot of index bits because we can be having. Well, I think no. I think that it might be enough because I think we're going to have 70,000 entities maybe. So I think we should be enough with 17 bits. So if we just do for now by shifting it by 17, we'll have 17 bits. So that's 128k. Right. Hopefully we don't have more than that of entities. So we can then shift. Yes, this one needs to and by. So let's get a full int to. Okay, so 0, so that's 16 bits. And that's another 16 bits. And then we want an extra 1 bit there. Nice, that's 17 bits. And then here we want to shift right by 17 to read that boy back out, and boom. So that's pretty sweet. Right, what else can we do to clean up this? Yeah, what else can we do to clean up this header file? So we include the generated stuff here. Then everything after depends on it existing. This ent range is the stores a whole bunch of stuff, but it just points to a range of entities within a single archetype pool. So we're doing a similar sort of thing. We're packing stuff down as we like to do. So I'm not going to make this thing typed because it is kind of internal, but it is publicly exposed. So the basic idea is want to pack all these things in. So yeah, I just got to figure out. So the archetype only needs 2 bits. We could just make them. Wait, how many bits we got? No, we can't. Yeah, so we did. Yeah, so we could do 21 bits each, right? It's 3 21s is 63. So we just did 21 bits each. That ought to be good enough. We could get the rest. So we'll just do like a archetype shift left. So that'll go that'll go 42. Then we all that with start index 21. Then we all the count there as well. Now I don't expect it to fill up 21 bits, but you should technically maybe and these things a little bit to mask out any of the high bits, which could end up oring into the other ones, but I'm not concerned about that. The numbers is way too big anyway, and I can't pack it down to a 32-bit integer, so this is all right. So given a range, we can take the range, and then we can shift right by 42, pull that boy out. Same thing again for the an entref. So an entref, you see, is going to be the mixture of archetype and the start index. Oh shoot, I see it now. I should probably move that one around a bit. Oh, that's okay. So I reckon we can go entref, put that in, put in the range, and then do like another one. And then what is it? It's going to be like I keep doing that. It's going to be like a int range start index. So that pulls out the start index from the given range. And then we want to add this sort of like entity index thing. So I think we'll call this like a relative index. Like that. And that should give us, so in the iterator basically, we get this range, and sometimes you just want an entity reference for one of those entities in that range of entities that you have, and this is a way of doing that. Yeah, but you're not going to have an offset like that. So I think I guess that'll work. Hey there, Kranzen. How you doing? How you doing, sir? Hope you're having a good weekend. You been up to much? This one is going to shift right by 21, and then we want to and the 21 bits, just so we don't get the archetype bits in there. So 21 bits, 4, 8, 12, 16, right? 20. 1. Cool. It's 21 bits. Then the end index is going to take the count and the star and add them together. It's just a convenience thing. Range plus bit of count, and then we need to make sure that we wrap in another bracket just in case, right? Because there's operators there. Could be a bit sketchy. And then the count one is just going to again do that range. That range thing, right? And just instead and 21 bits. So it's 1, 4, 8, 12, 16, 20. Like so. And voila. That should be end range done. So with the iterator, we basically have a way of getting some collision shape to say, hey, give me all the entities within this range. And you're going to get ones which are outside that range, because it's just going to do a collision test with the regions, which are basically chunks, like Minecraft chunks in a sense, like regions that the entities live in. So we iterate over the regions, or the entities within regions, based on that collision shape. So that's the iterator stuff. I think that's all right. We might get time to work on some of this today, actually implementing it, but I'm not sure. Why don't I see this? Oh, I didn't put a count on the type. Right, so let's go back to that code generator. So entity gen.c, where we do that archetype, whatever, right? We need to add another line at the end, same with the prop one, and just call it count. Wait, how didn't I use my my new context-aware print formatting? You know what I mean? Then it takes off extra lines. That'd be fine. I didn't need to change it. Right. So if you sound like that, rather than archetype, it'll be a prop. Hey, studying for exams? So, hope you finally get my degree. Awesome. Amazing. Finished with school. Beautiful. Hang on, Twitch is forgiven right now. Me. Awesome. What are you eating? What you got to eat? So this will give us a number of props in that enum, which is great. Yeah, a number of values in the enums, which will be super useful. Yeah, so why don't we regenerate some of this stuff here? So, let me pull some things. For crying out loud, I got to merge. No. Fine. I got it working on Windows. It was very small changes. I'll do it some other time. I just forgot to do a pull today. Wait a minute. What did I change in? Okay. That's all right. Let's rerun the code generator. It's pretty simple. I've got shell script. It just compiles it, runs it. Jobs are good. So let's do that. Seems like it's worked. So now if we, I don't know, change, there we go. So the LSP has now noticed this thing exists. I can go to definition And there it is. Yeah, that's cool. So I notice I don't have a pragma once in this header. So that would be a wise decision. So I think everything in here is looking good. Go to the next diagnostic. It's saying that this code generator has something fishy going on there. What about the next? There's just in here that's got the problem. Let's hop in here. So apparently, include, right. Why am I typing this? It's a code generator file. What am I doing? Go back to the code generator. And at the top of these gen files, so when we do our pragma onces, we should probably do a lovely little include of the entity H, just so the IntelliSense is satisfied. Pretty nice. What about the yeah, then the source code version. Yeah, that will need something. F open. It will need we want to include entity.h, I guess, as well. Cool. Yeah, so let's recode gen that. Let's hop into the actual codegen file. Right, so we reload. Reload. Well, the archetype pool is defined in here. Damn it. This is the problem with this thing. They include each other. I can't trust the IntelliSense really. Maybe we should get rid of the include in this one. Because the code generator one is included halfway through this one. Alright, let's get rid of it in here at least. Well, that's worth a try. The other solution would be to just put it all into one file and not have, you know, just code generate some strings into the top, like fixed strings, but it's alright. What's this complaining about? I don't get it. Anyway, let's go for the diagnostics. Oh. My headless archetype pools. What is going on with you? So let's do a git diff. I'd like to figure out what the crap is going on there. What do we remove? I haven't removed anything in here. Right, okay, so let's go to archetype pool and find that. What did I do? Oh, I deleted the line, didn't I? Whoops. So I changed to my new format aware. My new format aware printing function. Very simple. Sorry, context aware printing. So I just have these $1s. $capital A means the archetype name. So as long as we set this global variable, it's able just to work it all out. It's just scanning over every character, checking for the dollar, and if it's equal to the dollar, just doing the formatted print based on the identifiers of the archetypal property, right? And then it just puts a character in if not. It's quite simple. It's not the best code, but it works. But it makes printing a lot easier. So I forgot that function basically. Let's recode gen it. Let's pop back in there, check what's up. Yes, they're back in there now. No, they're not. Let's reload it. There you go, so they're back in there now, that's very nice. So if we hop back to this entity.h, it's still complaining about that, so it's 132. 132. Right. Unnamed type name Nightpool. Did you mean at Nightpool? Yes, I did. So that's in the archetype pool. Yeah, okay. So that obviously means easily fixable. So I'm missing the word ent. Codegen. Right, apparently there's no more errors according to the LSP. Sweet, so we should have... Right, well, what else are we missing now? Anything else? This is the entity system thing. Let's put another header in. So I think we're in a good place now to move on. This is the entity system. So let's call it ent system, then you say gn. Right, okay, let's just call it entity system. But it's not... naming is hard. Right. Good. So what is next on the agenda? So we've done the archetype pool, or the record pool. We probably need to do creation and deletion still, and we just need to we do need to do the iterator as well at some point. We also need to instantiate everything as well. So we need to be able to say entity system initialize, probably just be void, maybe, or maybe there'll be some strut that allows you to initialize it. You know, allows you to configure stuff. About it, you know, probably is a good idea. So I call like a spec or something. So we'll probably have the allocator in here, like how do we allocate these arrays? And then we'll probably also want like, how many entities do you want? Right, what's the number of entities that you want, capacity? Also, given all the archetypes, what are the archetype region capacities? So given each region, how many entities can you have? Region entity capacities. So that'd be quite handy. The initialization there. So there's something to do. So just pass in that spec. Do I call them spec? Let's go GPUH. Find out, forget these things. Yeah, call it spec. Cool, so there'll be a void. So that will initialize the system. Right, so what's the next sort of thing we could work on? So I guess let's work on the deferred destroy. Should we work on deferred destroy or the... Okay, let's work on the creation, because we did skip over that last time. Then the deferred destroy. And then we'll do initialization, then iterators if we've got time. So the creation is done via the Codegen API. We've not done... we've generated the headers okay, but we've not done the implementation. So we're going to hop into the code generator and find out the So it's called like init, right? Entity init. So here we go. So remember that record pool that we made? Well, we need to return this sort of typed handle here, right? So just code generating a typed handle based on the archetype. And this takes in, hang on a minute. Shouldn't that be a pointer? Yeah, it should be a pointer. All right. So we need to get back an entity ID using that new super love. Oh, wait. Entity record. And you'll fill it in with the reference. But the creation might be a bit more difficult. Right, so I think there generally needs to be a function. Nah, maybe it's just all Codegen, we'll see. So you get your record. So we need a way to allocate a slot within the archetype pools. So there'll be a coordinate field. Use the coordinate field to get, let's just type out the code here. And then we'll put it to strings. So you get the record by using that sort of like ent record pool alloc. That would be in gn.record pool, and you'll get back the entity ID for it. So ent ID, address of ID, jobs are good. Now we need a way to get the reference. Or we should have already had the reference to begin with. So the reference comes from, it has the archetype in there and the index into the right. So given the, let's go to Milton, just so people not aware can understand how this thing is structured. Satanic God, hey, welcome. How are you doing, sir? So you can imagine, right, it's structure of arrays. So you've got this coordinate property, right? And basically the way it works is that each region, so a region being these sort of like these cells, these grid cells, can have a bunch of entities within a region. So each entity can also be like a different archetype, so they'll be in a different pool. So we've got to be careful how many entities we have. We've got to have enough entities per region, basically, to warrant another archetype. So the knight has a coordinate property. It also has other properties which will have more arrays, right? Which will use the same index to get the same property out, right? Okay. But the way they work is they're not a contiguous list of coordinates, because then that would mean I would have to iterate over every entity in the world in order to find what I'm looking for. So instead, they're fixed allocated for every region. So we need to take that 3D region coordinate and turn it into a 1D coordinate. So if you guys have been following the rendering side of things, doing the BVH building, there's already a thing for this that we've been using called the Morton code. We could use that. And then things will be swizzled nicely. Yeah, you'll take this sort of like 3D coordinate, and that means the things that are near each other in 3D will also be near each other, or they'll be kind of near each other in 1D space. So say if you have coordinate 001 or region 001, you'll have a layer of 2 entities in there, you'll iterate over these guys. But if you didn't iterate, if your iteration collision shape does not hit multiple regions, then you're going to simply not search anymore. But if it hits the one above you, and to the left this one will be. Then yeah, you'll also look at these entities as well. But I don't know how many wins that will give. So basically we need to turn this coordinate into a flat ID. So we've got to be careful that if we did Morton, yeah, we'll do Morton. We should make it a square map, I think. We've got to be careful on the Z though. Z. Because if you're... So for those who don't know what Morton code is, it's called the Morton Z curve. Apparently this is someone else who came up with it as well. But I forget these things. So 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you'll notice there's a sort of micro Z, and then there's like a macro Z. And then there's an even more macro Z than that one. Right, dun, 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 dun. So the pattern just keeps repeating in these big old Zs. And you build a tree of Zs. And you're basically... So you're taking... So a 1D coordinate can address something in 3... Can be turned into a 3D coordinate. Right. And a 3D coordinate can be turned back into the 1D coordinate. So... It also works in 3D space as well. So, could I use this? See my concern? I might have to do something really funny to get it to work. Yeah, a bit fiddly. So maybe we can use more, do like some more encoder later. But I cannot be asked to spend the brain power on it today. But it would be more efficient. But we'll put it on it would probably be more efficient, but I cannot tell. So we can always do that later and just see what happens. But I'll put a comment in for it. So effectively, we want to take this sort of coord, which would be taken out from the entity. So it would be like a $A, it would be called in the Codegen coordinate. So we'll pull that out. Boom. Then we need to take this and make it and get the offset into get the region start index. So region start index, and so it'd be like int coord region start index. It'd be a function for it. So this is another thing that we'll be making. So let's just quickly make that now. It'll be pretty easy. We'll move it around. Crap happened there. Yeah, so I want to do something like return a flat index from a 3D index. So, oh yeah, and in the entity header, we probably need to store. We probably also need to store the size of a region. Region dims. How many regions? Wait. So region dims would be the dimensions of a region. Regions grid dims would be how many regions there are. So yeah, I think we'll need that to be passed in to the specification as well when you boot up the game. Right, so thinking about that one. When we are taking a coordinate This is just a coordinate in the world. You need to divide yourself into region space. So you get your sort of like region coordinate. So it'd be like a divide coord with the region, that sort of g-ent region dims, right? The dimensions of a region. That will get you a coordinate within region space. And then with this, we can flatten it out. So we're just going to do the classic flatten, but it's a 3D coordinate, so it might be a little bit more fiddly. Let's Google for that, because I don't want to mess it up. Flatten 3D coordinate. So this will not be efficient in terms of putting, it won't be as efficient as Molten Code, I don't think. I think it's like you need times the width, the height and the depth. Oh no, it's quite easy. I don't need to Google this. So you've got your, you get like a slice, size of a slice, if you will. And that will be gn.region dims y times z. So then the logic to flatten it out would then be, so you got your 2D case where you go, I've got my region coordinate dot y. So I've got this many rows. So the coordinate dot, wait, g-ent region dims dot x. So that's the width. So given a width of how big a region is, this is how many rows of those I have. Then you'll go plus region coord.x, right? So that gets you the 2D one. But to get the 3D one, you've got the depth in there as well. So like a region coordinate.z multiplied by a region slice dim. You know, maybe I'll just do it like this. Hey Lupo, doing good, my friend, doing good. Yeah, just been spending time with the family, spending time with my boy, you know, having a lot of fun. Yeah, it's so much fun to play with, you know, just playing with his toys and being silly. But yeah, doing some things like that. How about you? Been up to much? Right, so thinking about it now, I think that's it, right? So you've got your sort of like, right, and then we do a massive to do, right? Molten Code will probably be better, but we have to be careful. But like with Molten Code, it's going to try and make things square, isn't it? When we're going to have more rectangular things. But we have to be careful, but we have to do something a little more special. Is that right? Well, wait, because you've got, you have to do something a little bit more special. Yeah, we will. Because our regions will probably be... It's not just the regions. The region and the region grid will be rectangular. But yeah, so we'll do that later, and we'll see if there's actually any improvement in the speed. It's always good doing stuff like that, I guess. Later, you can always do a bit of a benchmark and see does it make my thing better. So let's just double check, right? So you've got like a Z coordinate, and you're saying this is how many slices of those do I have? So this is 1 times 1. Yeah, this will just be 1, and you'll be multiplying that by 1. Right, but you have multiple Zs. You'll be offset by a whole slice. Which makes sense, right? Wait, is it not Z, or is it X? A slice is X. Right, okay, I got that right. Okay, I got that right. So you can imagine, let me just draw it so things make sense. When you're flattening a 3D coordinate, essentially you got like a little cube, right? But we're not going to have to be able to draw a cube. So the first part is like, so the way the index will go is given a, I guess we'll draw a quick little cube. This is probably in the way of the chat. So you've got your x-axis, which is that, your y, which is that, and then your z, which is that. When you've just got an x coordinate, you always go across the x's first, in this case, because we've not swizzled it. So this one will give you a coordinate of 1. If your z and y are 0 and your x is 1, it will just give you return a coordinate of 1. But if you increment the y by 1 and say you've got a region, max number of regions of 4, you've got 2 more slots here, and then your 1, 2. So you would go, so your index would be 0, 1, 2, 3, 4, 5. So the mass would be, so it's y1, x1. So it'd be y1, x1, so it's y times 4, because that's the width, right? Y times 4, so 1 times 4, which is 4, plus 1, which is 5, as we wanted. Now, what happens if you were to put this down by 1 on the z? So you actually go behind and you go here, right? So you're actually, back. Hang on a minute. Let's make this a little bit more. You're actually back by one of these. You're here, right? And there. And I guess you're up by 1 as well. So that 5 then gets times by a whole slice. Imagine the y is like a 4 as well. So it'd be 4 times 4, so that's 16. So that pushes you back by 1. And then it'll be, so this would be 16. So 4 width, 4 height, times by 1, 16, plus another y, which is that 4. That 1 times 4. So that'd be 4, and then plus the 1. The 16 plus 5 basically, so that'll get you at 21. Sorry, 20. Yeah, 21. Cool. So that's how you basically flatten an index in 3D. But yeah, molten code will probably be more efficient. They'll be stacked up next to each other in 3D space, kind of that way. Things been okay. Allergic season. Oh no, allergy season. What sort of allergy do you have? Is it like hay fever, maybe? Okay, so that's that flatten thing, which is going to be quite useful, reusable. So with that, we get a region start index into that region pool. So we should be able to then... Oh, now we've got to allocate something. How are we going to do that? Can we get some bits? Where's my pools? I feel like we get to use some count leading zeros here. It's going to be amazing. Right, so in the entity... I don't know why I jumped around like that. Right, so here's our pools. So we've got a knight pool, we've got a chess pawn, a tree pool, we've got this header. So in the header, so the coordinates might go in the header actually. I think they, because they're going to be shared between all of them. We'll do that later. We want is allocated bit set. So we need to index into that bit set and calculate whether or not... Sorry, we need to then iterate over that bit set and find the sort of next free slot that we can... Yeah, find that next free slot. So you would get your int pool header. Maybe we could do this all... Maybe this could be shared. That'd be pretty sweet. So I can just call a function and I'll have to repeat it in the code generator so much. So we'll get the sort of pool header. So I could just call it pool probably. That will just be... Maybe that's passed into this function. So maybe it'll be like you pass in the coordinate and the int pool header pool. Just be like archetype alloc. So we allocate a slot from the archetype. Mr. Toggle, how you doing, sir? Raid and run, that's cool, my friend. Thank you so much for the raid, appreciate it. Hope you had a good stream. But yeah, welcome raiders. We're currently working on a entity system code generator because we're going to have a bit of a... We're trying to support tons of entities in our system. So we're code generating some C code from a simple layout file like this where we define some properties and archetypes and code gets generated. So I'll just give you a quick show of the game. We're building a game from scratch in C. This is like ray tracing some ellipsoids, and then we've got PBR as well. So we're taking a break from rendering, doing some more of the game tech plan. If you're interested in finding out more, I've recently done a devlog about all of that, so you can catch that up there if you're interested. But yeah, if you have any other questions, feel free to ask away. Happily answer any questions. So yeah, we're just trying to allocate some archetypes right now, or entities from an archetype pool. So in my sort of core header, do I have that bit set stuff that I usually have? Bit set. Amazing. So this core bit set is set, and core bit set and unset. But I don't have like a... we should probably... right, so I guess we're going to bust out some intrinsics then. So there's a bit set in the pool. So we need to say bit set is allocated bit set. And we need to somehow like do this I think we need to use right, so let's go to my maths stuff. I got this a bit least significant. So we want to find the least significant bit that is not set. And this says if it's 0, it returns all bits on. Okay, so we get to use a bit of count leading zeros. Yeah, so I think we need to index into this bit set using region. I think there needs to be some kind of for loop as well. Yeah, we need to iterate over all of the 64-bit words. So in my pool, I need to probably have like... Oh, no, no, no. I don't need any of this. This is just a bump allocate away. U32 count, U32 capacity. What's the capacity of this archetype? And what's the... How many entities in this archetype and how many entities can it have before it fills up? But those counts should probably be stored in another array somewhere, I reckon. Because when we're iterating, we probably want to check if they have any in there. No, we'll just stick them in here for now. So we'll store the counts each region. Region count. Yeah, we need to allocate that. Okay, that's interesting. So we can just bump allocate those entities. I did forget these might need to be... Yes, that's a region start index. So we can get our relative entity index, which will simply be, given the pool, look at those region region entity counts. Index with the region, already a region star index would be a region index. Region flat index. Then with the region flat index, we should be able to get the count, and then we up. We up the count as well. Then we should probably assert that we've not filled it up. So the capacities need to live somewhere. Maybe we'll leave them. So we should probably say like core debug array resize. Pool +1, make sure that is within the range of G ent. What did I call it again? This archetype region entity caps. Yeah, we'll need a copy of this in the entity system array, in the entity system as well. But yeah, how many archetypes in a given region can we support? So for the archetype, so we need the archetype to be passed in as well. So we'll pass that in. So we just need the archetype then, because we can get that pool. Ent pool header. Pool is equal to G ent archetype pools archetype dot header. That should do it. Take the address of that. Okay, so you get this region flat index. Use that to get your next entity index within the pool. Do the lovely assertion there. Then we need to mark the bit set. Do we need an is allocated bit set? Because I don't think we need an is allocated bit set anymore, because they're always going to be contiguous within a region. When you free it, you're going to just remove them. Take the one from the end, overwrite the one you're trying to delete. So I think this is allocated bit set can just get trashed, really. That would be pretty good. I'd like that a lot. That needed to be an array of things as well. That was wrong. Okay, so I don't do anything there. That's even better. Then we should have an entity reference. So to get a base entity ID, entity index, we take the region flat index and we times that by the capacity per region, which is also here. So entity cap per region. So we'll get that into a super lovely local variable. And then we shall multiply that here. So now you got this sort of base ent index, and you should be able to construct yourselves an entity reference now. Ent ref, chuck in the archetype. That goes in the high bits. Then this goes in the low bits, and voila. So I think we're nearly there now. So after you get the record, you set the reference up in the record. So we've got a longer living in ID rather than one that can be shuffled around. And then we simply return, what are we returning? So we allocate an archetype. Or, will we be returning? Probably just the ID, right? So it can be made a typed ID. Although, no, we need to fill stuff in. We should be returning a reference, maybe. No, we need both. Let's just return a couple of pointers. So we'll have an ID out. Yeah, we need two indices. Hey, Meatball. How you doing? Or George. How's it going? I remember. ID out equal ID. So really, actually, this should just pass into here, and we don't need it locally. Just go all the way through. And this would be ref out ref. That'd be pretty sweet. So I think that's what we need. I simplified things a lot. So let's just double check all this code we're written out. Entity coordinate region flat index. Take a coordinate in the world. Right, it's on a tile grid. We're divided by the number of regions that will truncate. You get the region you're in. We probably should use more code in the future, but let's just manually flatten it using the classical way that you flatten a coordinate, right, where it's along the x first, then along the y, then along the z. Then this alloc function takes in an archetype coordinate, takes a couple of pointers to return some stuff out. You get the pool. You get the flat index of the region. You then get the number of entities for a given region. And then you bump it up. So you've bump allocated a slot. This is a relative entity index within a region. You then get the number of entities per region. Make sure that you've not overflown. So the way that I look at it, so we need to either return a way to safely fail in this case, because you're going to be moving entities around as well between pools, between regions. So we need to be careful on how we like. You don't want to have a boolean on the initialize, right? Yeah, we'll think about it. The assertion's there anyway, so we'll catch it. Kindly remind me, is this some kind of Vim VI variant? Yeah, it's called Helix. It's written in Rust apparently. I'm looking at my Vim. Yeah, my Vim or NeoVim config decided to throw a bunch of errors one day after updating my system, so I decided to rage quit. I was kind of looking at rage quitting anyway. I was just waiting for the moment. But yeah, it comes set up out of the box with a lot of stuff. Quite happy with it at the moment. I'm just trying to learn my new key bindings because I've customized everything. But yeah, there are a few things about it that I wish they would have just done already. Like very simple things. Like if you do like a single line comment and press enter, it does it literally. It doesn't like keep going the comment. If you do the hash symbol, it doesn't go back to the beginning. You know, I guess the person's a Rust programmer, so probably an underside there. But maybe it's configurable in the LSP, but it shouldn't be. It should be default. But most defaults are pretty good in this, though. I will give it that. Quite happy with it. Yeah, I've defined my own key bindings because I got Cormac keyboard layout. I've had to do it all because in a terminal, you don't get scan codes, like positional key codes. You just get virtual key codes, the ones that yeah. So I've had to change everything around. That's cool. It's completely custom. So your base index by doing the region flat index multiplied by the number of entities per region. Now you need to add the relative ent index onto the base index, and voila, you'll have yourself a reference. Then we allocate a slot in the record pool, which you saw, which was super cheap, and then you put the reference in there for the super sturdy ID, so you can pay the cost of the indirection if you want to do random access. But yeah, we shouldn't want to do too much random access, but it will have to happen. It's optimized around the iterator system anyway. Right, so these two things can go in those super lovely non-generated header files. So there's like an archetype one. It's kind of internal though, but I've decided to make it's definitely internal. This is silly. You know what? Maybe we'll just make it static and put it in the just put them in the at the top of the nc.c file. And that'll do. So this should be including the Codegen file. I don't see it. Let's do that at the bottom. Include entity generated. .c. Cool. So back to that code generator. So we're going to go ahead and made those lovely functions. So when we instantiate an entity, we should be able to instead now get back an ID. Programming in strings. Isn't it lovely? Going completely off topic, but it is something that irks me a lot, and it irks me even more that the only ID I know which actually gets somewhat right is Visual Studio. Okay? When you edit your piece of code, most editors use their own parser or whatever. What this means is that whatever information you get in your editor is about the quality and correctness of your code. It's some random parser that we'll never use to create the actual executable. Right, so you're saying, does the Visual Studio one use the same parser for MSVC then or something? I don't know. But whenever I'm in Visual Studio, because I use it at work, right? It's very clunky. And I would say it gets a lot of things right, I guess. But it also gets things painfully wrong. You can press the F12 key and it's like, hang on a minute, this function is called init. And you've got 57 things called init. Which one is it? And it's not able to deduce the type and figure it out in 2024. But when I'm actually writing it, it's probably all right. Yeah, I would say that's probably fine. In the editor, it tells you there is some error, but you run it a build in Visual Studio and it compiles just fine. Yeah, they do stuff. They do stuff that's really weird. Also, it feels like they've got someone who comes in and just messes up the code base. Like, there's a new bug that came in. Yeah, so there's a bug that came in with the whole sort of like you put a breakpoint down. Or not even that. Yeah. You put a breakpoint down. You hit the breakpoint. You go up in the call stack, and it's all off by one on which line it's on. There's other things as well, like there's a new recent one in Visual Studio where what is it? Oh yeah, very simple thing, right? I control tab to another file, right? I just switched to another file. All the syntax highlighting is gone, and I haven't actually switched to that file yet, but for some reason, this is the new bug. It's not actually switched to the file because then I can't do anything. When I click on the screen, it changes me back to the previous file. That's a new one that they've added. It's just so bizarre, the classes of bugs they get in this in the editor. It could probably strip out 90% of the bloat. I recently updated to 22 from 17. Pretty much everything is worse and slower. Yeah, well, I don't know. I think they're probably suffering in complexity. And it's probably just a case of like, well, if we write this, it's going to bring in a whole bunch of problems. And they're all just convinced themselves that they can't really do much better. You know, it's very difficult to solve problems like that. Like, you have a whole team of people, and this thing has been made complicated. And needs a serious effort to uncomplicate it. Yeah, I think the debugging experience is probably the best somehow around in Visual Studio. Obviously, there is that bug I just mentioned, but it's got watch points. You can set breakpoints that happen programmatically quite easily in the UI. You know, it's kind of a nice experience. Obviously, we could probably get a better experience than that. Yeah, quite ideal. All right, what was I looking around for? Haven't I included? Six. Oh, this hasn't just added it. Strange. This exists, man. Okay, just ignore it. I added a float rather than an int. Righty, oh, so. Yeah, so. Let's go back to the code generator. Right, so I wanted archetype and alloc. Archetype and alloc. We pass in the archetype. So that is ent archetype, then the capital A thing, that'll be the enum. Then we pass in the coordinate, so that'll be $A coord. Then we pass in the address to the ID, then the address to the reference that we want back out. Voila. And then we should, hang on a minute. Well, I've got commas here. Now we should be able to return. Right, we got to set every field within the. We got to set every property Have I got those functions in the code generated file? Generate.h. Yes, I have. So I could just call these functions to do it. Manually set them all up, calling these setters. Or I could no, but these are very simple. I'll rather manually inline it, I reckon. If I go into here, look at the typed getters and setters, they're just going into the archetype pool and yeah, doing a set. It ain't too hard. So let's do it. So basically, right, we've got to do a for loop now from within here. So I reckon we can right, so allocate a slot in the record pool. This is past me, see how correct I am. Bump allocate a slot. See, past me got it right, bump allocate, and then there's me going through this bit set for a second. Set every property, yes. Set the ref, I've already said it. Return the slide, okay, got it. Right, that's cool. Let's keep going. So what we're gonna do is go ahead and print that out, that lovely format, and then we're gonna go again. This time we're gonna have a for loop of all of the properties of the archetype. So was it like prop index, did we call it? Search for that. Right, that's what I want. So given this archetype, go over all the properties in the archetype. Now what I would like to do is do another print format. And I probably need another lovely one of these formats, please. Then, so what I'm trying to do, I'm trying to get basically this line here. Well, no, it could just all be done in one line, I reckon. I don't know. Yeah, still in one line. Surround those, beautiful. Then we replace with the formatted stuff. So that's capital A for archetype, lowercase a for lowercase archetype, then the property, so that'd be P. Then we index with a specific index, which comes from the reference. So you should probably stick this in here, where you should be able to extract the entity index. So ent index, which would then be ent ref index ref, something like that. So then here you can just say ent ref or ent index equal, and now this archetype pointer that gets passed in, so it's just called lowercase, whatever the archetype is, and then whatever the property is called, and we're storing it in there like that. Semicolon. Jobs are good. And then we should be able to finish up with, yeah, we should be able to finish up with a close bracket and a couple of new lines, and that'll do the next in it. So let's code gen that, see what happens. That was quite involved, but that's entity initialization, hopefully. So we code gen. Right, seems to have worked. We hop over to entity gen.c, generate.c. We then do a lovely reload. And now we find our functions. So here they are. They're kind of looking all right. This is complaining. Why though? Because I believe. Oh yeah. It will be complaining because the generated file is included by the non-generated file. This is fine. Called it like an entity index, didn't I? Well, that'd be better. Right, so then we, this is kind of dumb, doing this all the time. Right, we should probably get this into a local, at least. So let's go ahead and do that. So basically we want to do an ent archetype pool type. We could just do pointer pool, and then it would just be whatever this part of it was, right? It would be then pool dereference, and this just gets replaced with that, like so. And then see how that goes. Generated reload. Right, I did a dot night there like a melon. Really, we should be doing the dot night here. And then not doing it there. Okay, so then if we hop over to the generated reload. Sweet, that's looking better. So we get the pool. Should have been an address. Damn. But yeah, that's basically it. So I think that's any problem. We'll just change that. So that should be the initialization. Now, you can take a pointer to a single entity structure filled up, actually create it, get back a typed ID. Oh, we didn't do the return. Right, did the address, then the return. So tab return ID. Then we do the address of like so. Cool. So that right there is the initialization. We should probably move now on to the deletion. So the deletion is going to be deferred because we still want to be able to iterate over entities and things. And maybe should the creation be deferred as well? Because if I create another entity with it while I'm iterating, I may or may not hit it. Sounds a bit daft, doesn't it really? Yeah, it sounds a bit crazy because you could have already been past the pool and then you've... Yeah, so maybe actually we should make initialization deferred as well. So we make it deferred. Then the concept would be you put it on an array. You still create it, but the counter doesn't get incremented until the next. But then you got to copy all the counters when you start a new frame. And that's a lot of regions to copy over. Yeah, it's a bit silly. Yeah. Right, why don't we work on the deferred destroy one first, and we'll come back and probably make this one deferred because it makes sense. So the reason why I have the deferred destroyed is, again, because you're iterating over stuff and you don't want to be able to like mess up the iterator basically. Like, because depending on how the iterator works, you could have passed that entity and like it could be inconsistent. The behavior being consistent. So we defer destroy them, it should work out fine. So the deferred, we have a function in the entity.h called delete deferred. So probably called deinit deferred. So deinitializing entity deferred. I think this is probably made. I have my go-to reference, but it's not working, I think. No, I've not made this one. Yeah, these are going to be probably Codegen. So let's see if we can implement this one and just figure out the shape of it. So we've got that sort of like record pool. I had that delete linked list, but then I don't. Yeah, I should probably just allocate an array of indices I want to delete. So we'll probably just say record pool q deletion q deinit q dealloc. So yeah, we can just q deallocate in. Oh, yeah, so you probably need to go from a record, like a reference, to an ID, and then queue a dealloc for that slot, and then it'll be able to. Yeah, so the faster operation will be able to deallocate with an ID at least. But we need to support both. So we should add support for this. It's quite easy. I think it'd just be like an array, basically bump allocate. So we might just use a stack. Dealloc q. So it'd be like a core stack push. We're going to push on ID, basically, I think. And then we can iterate over all of those. Yeah, we can just iterate over all of those. So in our record pool, I think we'll just do the core stack of U32. Or it could be nref, but U32 probably works fine. Dealloc q of entity ID. This will be a raw field. I can't remember. You know, we could define stacks for them. It's not difficult. Core define stack ent ID So it's just a global array. Nothing too special. Just declaring the type for it. So we can then yeah, so I guess here, right? We'll just do an int ID. Nice. So I should be able to push without the raw there like that, and voila. So then when we do that deferred dnet, I think it's literally just as simple as going into the pool, int pool header, so that'd be g int archetype pools. We can get the archetype by doing a int ref archetype. It's stored in the high bits, thankfully enough. Then we can simply get the header part of that, take the reference, and then we will, in the pool header, there's actually some, there should be another array. Record indices. What does that mean? Right. I see now. Int ID. It's an array of record IDs. So for given every entity, like if you have a reference, you can turn it back into an ID in this case. Because if we iterate over entities, we've got to have a way to get it, to turn it back. And the quickest way would just be to store it per element in a pool, basically, which is 4 bytes per ID. That'd be fine. So it should be quite easy, right? Go into the header, get the record IDs, simply with your entity reference, you can now say int ref IDX, int ref and that will be your int ID. And now we should be able to call a different function which does the deferred dnet, which will probably just be called int dnet deferred, because we've got the creation as well. Something like this, right? We'll probably just call this, which ends up probably just calling, add it to the pool of deferred, or the queue of deferred entities. Okay, so there's one function. And then this one here will probably be, we haven't implemented these two actually, is it? Also. Right, I guess let's just implement these functions. This one already exists. Perfect. So we'll just carry on, finish these ones up. So there's this, for entity reference, does a property exist? But that's just like this one for an archetype. Yeah, so that would literally just be calling Yeah, I think this meant something else before, but we'll make it a shorthand version of oh wait, ent ref archetype. Passing the ent ref and the prop. Cool. So those two are now implemented. Let's implement the other ones quick. So to get an entity reference from an ID, remember we've got that lovely pool. Now it should just be a one-liner, I think. So we should just be able to say return ent record pool get with the address of gent record pool, followed by the ent ID, and then deref that and get the ref, and voila. Then the deferred dnet we'll just call the queue function. So that'd be like record pool gent dot record pool, just push that on the key, basically. Right, so now we've just got to find a place for these to go. So these should probably just go in the non-generated source file. How far away from something that we can run? So we've just done entity creation, we're doing deletion. We've got to get the deletion, deferred deletion to actually do the deleting. Deferred. We've still got to build the iterator implementation. And then probably defer the initialization of entities as well. And then we just got to get it compiling after that. And maybe the initialization steps. But yeah, we're getting closer. I wouldn't say it'll be this stream, but it might be the next stream. Getting it all together. Should be pretty cool. So it's the record pool. So I think we'll do another one for references, IDs. Entity reference, entity ID. So we should be able to grab those implementations. Get over here. Drop. Find the implementations, grab them, go over here, plop them in here. Nice. Cool. So that's the deferred queue. Filling up at least. We need a way to actually do the deferred deletion. So something we're missing is kind of like I've started a frame, I'm ending a frame. I don't know if we're going to need to do anything. So we might just have a frame, like when you begin a frame, perform all the deletions, perform all the creations, and then I don't think we need a frame end. So this would be an API that we need, so let's go ahead and get that in there somewhere. This would be in probably after all of this, I imagine. The initialization might actually be a bit, might be Codegen. Let's just do this one. So when we start a frame, what we need to do is go over all of those number of queue count, or that entry count, I guess we can call that. Entries count. So that'll just be in the record pool. Hey, these are the ones I want to delete. And we will, where did the, I'll put this back on. This was good. So it's like a core stack count. Then we do a index 0 entries count. And then we need to make sure that we actually clear it. So this will be the deferred deletion. This will delete at the start of the next frame. Why did I capitalize that? Then we do a clear. So all we're going to do, it's pretty simple, is do a entity record pool, deallocate, and we're going to deallocate that slot back. So record pool, deallocate, I guess I'll put it in a local, ent id g and record pool, deallocate queue, data index, nice, and then we simply just pass in the ID like that. That should be the deferred deletion. Not anything more than that to it. So now we'll figure out how we're going to defer create. Right, we made those lovely create functions, but I think they might be problematic. Like if you create something within an iterator, that's gonna create some problems. We could, like the iterator is just gonna get a range of entities. So within a region of space, say if you have you want to see all the entities within this radius while you're inside this whole region here. So we look for all the entities within that region. Within that region there is so imagine it's this one here, there's 4 entities. Halfway through the iteration, you've added another entity. Or maybe when you're iterating over some other entity, you've added another entity to this frame. But you don't want to include it when you go here and start iterating over these guys. And the way my iteration API works, unfortunately, is that when you go to the next archetype or the next region, it works it all out lazily, right, as and when it has to. So it would pick this one up in the iteration. So we need a way to be able to not include this one if we instantiate it right away. Or we should just bag the data somewhere in a queue. And then, yeah, bag it somewhere in a queue. And then simply just apply them all at the start of the next frame. So apply them all at the start of the next frame and bagging it in the queue seems like the fallback option if I can't get the other one to work. Because that one's just really easy. It's an extra copy, it's an extra section of memory you have to allocate. But yeah. Right, I'm just going to take a quick break, go and fetch a drink, and then we'll come back and solve this problem here. BRB. Right, welcome back, folks. Got myself a nice fine glass of H2O. Yeah, what we're doing, entities and stuff. If we're iterating over a bunch of entities and we add a new one, I want to make sure it doesn't show up. So I was thinking, I think the only way we could do it is that in our where is it? The pool, in our pools, right? So this goes to the pool header. The bit that's shared between all of them is like inheritance. We've got this sort of region entity count. So you index this with the region index, and this will get you the region, right? This region that we're looking at, get you the number of entities. So the only solution I could think actually exists, if we're gonna, when we add new entities, we just put them in there, is that we simply, well, it's not simply, this is the problem. We have two of these, or a second one. Yeah. So you have two counts. One is this frame, the other one is the next frame's count. And when you start the next frame, you go over all of your region counts and you just copy them over, right, to the next one. And we're going to be using these region entity counts in the iterators to get the ranges. But I feel like that's going to be... we're going to have a lot of regions, I think. It's 3 dimensions. So I feel like, this ain't a compute shader. This ain't a way to solve it, I think. Double buffing the entities could be an option here. So just adding a still alive and new entities to the next buffer, then clearing out the current one at the end of the frame. Right, I see. Yeah, I've seen that approach. So I think Dreams used to do that. It used to essentially have a game structure where everything lived, and it will copy it all the way, which would be fixed allocated, everything fixed allocated, and copy it from one to the other, and readjust all the entities into the right place. But I want to try and avoid the double buffering. But yeah, you're right, that is a solution, but that involves a big copy. Which is probably... yeah, it probably isn't that bad. But I'm complaining about copying a bunch of 32-bit integers. So... yeah. Yeah, I don't want to do like thousands of... well, it would be like thousands of integers, wouldn't it? Probably. Yeah, so that's this one approach. Yeah, maybe I'll double buffer the region entity counts and copy those. Because the other approach, see, I think it's going to be in the thousands. The other approach is to have a queue of archetype entities that you've added this frame that will get added in. But the problem with that solution is that I've got to make a queue for each of my archetypes. So I have one big region of memory that we allocate from for that, and then it's just an extra region of memory, and I guess that could fill up, so I've got to max allocate that efficiently. But I could waste memory, right? I could just do 64K of it. Yeah, I'm just going to do the double buffering approach for now. It's probably the simplest. Next frame. So whenever we do that create now, so whenever we do that sort of init. See, I'm so used to using the word create because at work we use create and destroy, but here I use init and dinit, and my mind is shifting. So init. So where do we up it? Oh, it's this one, isn't it? Entity.c. Perfect. So we up the next frame array instead. So we up that number. The iterator uses the other one. And then at the start of the frame, we're going to go over all the regions of all the archetypes. So here we'll just say defer delete, defer dinit entities. So execute the defer deleted entities. And then here we're going to update the region entity count to fulfill. How do you even spell this word, fulfill? Screw it. Update the entity region entity counts to complete the deferred created entities. So that is simply going over all of the archetypes. So archetype 0 ent archetype count. Is it really fulfill of that? Fair enough. I saw it there in the completion. Now I know. See, I've never spelled that word before, I think. I've always just said it. See, we always pronounce it as fulfill. And it makes me concerned that the Americans don't say it as fulfill. Because Americans would do that. They would look at it literally and say it as it's read. Whereas English is always meant to be wrong. You're never meant to say any word correct. True English. So go over all the archetype pools with the given archetype, check in the header. Then I guess we'll get a pointer to that as well. Right, ent pool header. Then we simply are going over all of the regions. So I don't know how many regions we're going to have, but yeah, I do. Regions count. GN region grid dims. Right, and it's the good old product elements. Give me a product of it all. Right, XYZ multiply together, please. So I've got like a region index, regions count, and simply so region index equal call region next frame. So hopefully we won't have a massive amount of regions. If we do, the other solution will be better, but this is the easiest to implement. So that'll be all right. So that's the third create and destroy now. We've just got to rename the functions though, because currently they are named in a very weird way. They're named without the deferred thing. So if we say generated, so it'd be, yeah, you go, night init. But now this is deferred. And this should really be called some deferred thing as well, because I think at least. Alloc deferred. Something like that. Yeah. So back to the code generator. Let's go full ham. Init. Right, so init deferred. Same again. Then this is deferred as well. And that should be everything we need to do. What have I done? Did I include the generated file in my source code of my generator? What? When did I put that there? Cool. So now it's code generated. Let's take a look at the output. So generated.c reload. So we go, we call it deferred function. It's got deferred at the end now. Pretty nice. Right, so we've done the create. So today we've done the record, making the record pull. We've the whole API and implemented it. We've deferred deleted stuff. We've deferred created stuff. Now more. So I guess we can work on the iterator stuff. Or the iterator one's going to be quite fun. I think we could get that done today. And that should be basically everything implemented. Besides initialization. Yes. What the crap is this? What? So we're setting a value of property. So there's the property name passed into the function. Cool. All right, let's sort it out. Yeah, so the iterator sounds quite fun. So let's work on that. So a quick recap of the entity iterator API. So we designed the API and the usage code together, and it did go through a few phases because I tried to implement it in my head, or sorry, as a sort of prototyping the implementation code and the structures, and it did change a few times, but this is what we landed on. It does everything basically, so it's going to be a bit of it's going to be a thing where you're going to have to copy paste the iteration API, but it's okay. I'm happy with that because of it allows me to do SIMD in the future. It allows you to filter out different archetypes, pick between different properties that you want and don't want. It allows you to select within a region of things. So you can say within this radius, give me or iterate over all the entities. And it will give you ones that are outside of the radius as well, but that's okay. And then you can iterate over things sequentially in arrays and hopefully get good performance. So yeah, we have this type of like, you have to instantiate the iterator, pass in the archetypes that you want. Here's the region you're in that you want to look at, and there's the radius because it's the radius operation. Then here's a list of properties that we want to find and not find. And now we iterate over all the archetypes, go over all of the different regions within the pool, and then actually iterate over each entity and perform the operation. And we can do deferred deletion as well if we want to in here. So it's pretty sweet. So basically, if we go to the header, entity.h, you will find that there's actually some internals being exposed because I want this to be able to be stack allocated. Yes, some of these internals have been exposed. Same with this object pool, really. Why? Yeah, maybe I should work on moving some of the private stuff internally. Anyway, we'll figure that out. So back to the iterator. We've got this range thing, which basically gives you a range within an archetype pool, start and end index, and an archetype, obviously. We've got this shape thing, which allows us to pick different shapes to figure out which regions to search in. So imagine if you have like an entity here and it has a particular operation it wants to perform, and it has a viewing cone of this. We would then only look in these two regions for entities, and all this is doing is a cone versus bounding box for the region, and we can test to see if we just, we can get the bounding box of the cone and test over all the regions in that bounding box against the cone. So yeah. And then there's like a radius one as well. We haven't done the cone one yet, but we've done a radius one. Same thing, get the bounding box, then iterate over all the regions within that bounding box, and then do a ellipsoid versus bounding box test. If it passes, we look inside that region. So yeah, we saw the shape, and yeah, the API is all going to be the same basically. So we need to implement these functions. Yeah, so this, where is it? Yeah, so we don't store when we create the iterator, we don't go and check every region and then get a list of regions. Because I want this API to be able to iterate over the whole world for debug purposes. So I don't have to store some big array. But in the future, it might be more beneficial to store an array in there. But for now, it doesn't. So when we instantiate the iterator, we essentially just create the same object, and it has all the state that's needed. just with a different shape. And then when we call, so it ends up calling into this one basically, I think. And then when we call next archetype or next range, it will then do those specific shape checks in there. So I guess we could just write out the meaty function first, and then the rest just fall into place. So yeah, the thing where it does when you say next range, it's going to be actually going over all of the, let's just do the iteration of next functions. So when you've got archetype and archetype filter is just a bit set of each of the archetype. So we should be able to use a single instruction. So bit least significant bit that is set. So it's like count trailing zeros or something like this. It's just a platform agnostic version of that. For a U32, I want to use that one. Wait, what is this? A U8 maybe? U16, yeah, actually. But whatever, so you do the U32 one. So we'll say iterator archetype filter. Now we need to be able to remove the bits that we've already iterated over. So we need to and off a one shift left of archetype. Take one, I think. So I'll get you the bit, I'll get all the bits before. Wait, is it including this one? Yeah, you want to remove all the ones that came before. See, I wonder, should we start off on... Yeah, we should start archetype off on -1. So we increment it. Yep, so this will get us the next set bit, or the next archetype. So just to break that down a little bit for those who don't understand. Filter is a bit set. So, and this is an enum. So say if night is enum 0, the chest archetype is 1, and the tree archetype is 2. Say if we have a filter, these are the bits now. So we have a filter where we say we want to search over all of these, over every archetype, but we've already looked over all the knights. So what we're going to do is we're going to you've already looked over all the knights, but we're looking at the chests. We're going to shift right by 1, because chest is 1, and we'll end up here. This bit will be on, so we'll produce a bit set, a bit pattern like this. We'll take away 1, which makes this 0, and then that bit 1, and then we AND it with this. Wait a minute, we want to knot it. Glad I explained it there. So we knot it, that'll produce a 110, then we AND it which will then produce... Wait, these will all be 1s when we not it. Yeah, then we AND it, which will produce this. So then we do the get least significant bit index. So that will get us 1, which will then be chest. And then this will just be the chest. So really we could say it's a archetype. Yep. So you would say yeah. Next archetype probably self-explanatory, to be honest. Yeah, so now you've moved to the next archetype. The thing you would want to do... Wait a minute, did we gonna say... The way the iterator API seems to be working at the moment is that we are doing a while loop, which means 0 should be a none. Okay. So 0 is... We need to add a none slot. Let's do that quick. So along with this count, we should also have a null or a none. Let's do that. It'll be nice. Right, so back to where we were. In entity.c. Oh, we weren't in there. It was in the header file. Just toying about. So this means, so this can turn all bits, it can give you back all bits on. So if all bits are on, so we've got to be careful here actually. Next, archetype. Well, you know what? Filter without previous. Archetypes. That's a good name. Filter without previous archetypes. Rightio. So if this is 0, then you have reached the end. So we should return 0 ourselves, which will return ent archetype null. Then that will iterate to the next one, and then we shall return. Archetype. Cool. What's the problem? Nice. So that's the next archetype thing. We've got to remember to instantiate this to -1 to all bits on, so the increment will work properly the next time around. So they keep calling into this, it will keep incrementing this. But that's okay. They've got a long way to go before they overflow, I think. But a more correct one would probably be A more correct one would also have an if this is greater than or equal to archetype count, we're also going to return a null. All right. So the next one would be, wait, hang on a minute. It's got to be equal to -1 for it to wrap around. And then we've just stopped that from happening. So maybe we instead initialize it to 0 and then increment it after. All right, that's okay. Sweet. That works. So with the next range, this is where the we're going to be going over all the regions now. So within the iterator, we have a region index and this sort of bounds that we're going over. So we're going to go over all the x's and the y's, and this should already be 3D. Yeah, this should be 3D. Yep. So effectively, if our region index is greater than or equal to the end, we're gonna return null. If all E30, it'll be an S32. If all of the so if this is greater than, what is it? It's a region index. So it's a 3D index. If that is greater than, it's a region end. Greater than or equal to. Then we're going to return 0, meaning there is no more ranges in this archetype. So the next thing would be, so I think we could probably do the ending. Where you'd need to increment the 3D region index along the x. And then if the x is equal to the end iter region, if that is equal to iter region end dot x, then we need to wait, isn't that an any? Might be an any. If any of them are greater, yep. Then we need to put region x back to 0, or back to iter region start.x, and then set the y, increment the y. So you can imagine, hey Frank, it's Andy, LinkedIn. Do you want to see my LinkedIn? I have it linked somewhere. I had it on my Discord at one point. Yeah. If you... Yeah, I'm not sure the best way is to share it, to be fair. So Frank, are you in the industry as well? Are you in the games industry? Are you a fellow game dev, my friend? So say if we have a radius that extends like something like that, we get the bounding box, and we're basically every time we call get next range, obviously it starts here, it will go to the next one, then it'll go to the next one, and it's doing that sort of collision test as well, but I'm just showing the iteration step. When it reaches the end, right? So we iterate up to here, be like, oh crap, I'm off the edge. Resets this back to 0 and increments the y, right, and then increases. Right, does the same thing again and again and again, right? Cool. So we've got to do the same thing for the Z. Same thing. If the y has been incremented past the end, we've got to move the y back to the start along with the z, right? No, because the z would have gone, yeah, back to the start already, yeah. And then this one would have happened. And then we increment the z. Right, you don't do a special case for the z, so then this triggers. Right, so really what you're looking for is if the z is past the end. So really it's just one check. If the z has gone past the end. The other one's more safe, but yeah, the other one is more safe. Screw it. Yes, that's the sort of stepping thing. But we need to return a range at the end. What's up, wavefront surfers? How's it going, Raymarch? How you doing, sir? Right, so how do we make this range? So we first got to figure out if do that collision test. So I think this is one big while loop. Getting that while loop. And so you just keep going round and round and round, and you gotta try and see if you get a collision. So you check the iterator shape. Good old tags union. Case int iter shape. If it's an ellipsoid, shape type ellipsoid. Doing great, how are you? Nice, nice. Yeah, doing pretty good. Just been chilling out with the family, you know, playing with the baby, hanging with the wife, working, you know, those sorts of things. But yeah, things going good. It's my wife's birthday tomorrow. Plus, it's a bank holiday. Right, whatever that is called in the US, it's a bank holiday. So yeah, just gonna be celebrating that, really doing some stuff. I wouldn't know, I'm German. Fair play, you're German. Ah, sehr gut, sehr gut. My German is very limited. Ich bin Henry. Yeah. That's about it. Sehr gut. What does that good mean again? It's like this is good. Does it mean this is good? Or that's very good. Very good. Okay, that's good. Amazing. Yeah. There's also the word like wunderbar. Wunderbar. Is that right? Oh, that means like wonderful. Easy peasy. Excellent. Amazing. Yeah. See, the bit that got me about German, which is kind of funny when I was learning it at school, is like in English, you go like, I played football. Or you go like, I played football, that's it, right? And then like in German you go, I football played. So I can imagine there's so many jokes that just don't translate because the sentence structure just changes. And obviously there's probably a bunch of other words that pad in between here. And also like to the level that also trying to understand what people predict what they're saying with their sentences will be different as well. With the K's instead, right? Eigenvectors, right? It's surprising how many jokes do you translate. Oh, okay. Interesting. Right. Yeah. Surprising. Very surprising. Yeah, so we'll do like an ABB verse ellipsoid thing. Can we steal one of those from somewhere? We could just do a bounding box check initially. The thing is, though, it's like what type of it will be. Yeah. You know what? Let's just not do it for now. Let's just say returns true. It always collides, right? But this one would need. You would like. Do they say ellipses in a 4x4? Probably not. Yeah, just translation. Like, I think as soon as you rotate it, the answer is probably no. Yeah, so there's the problem. If you take a sphere and you try to. There's a really common one. Take a sphere and project it to the screen. It's quite a hard problem. Like getting a bounding box around a sphere on the screen is quite difficult. You can do a rough guess quite easy. But yeah, getting a tightly fitting one is quite hard. Well, for me at least, my maths is like terrible, but it's more involved. Yeah, what are we trying to achieve here? So you go to the next region. You should have probably got the region that you're looking at, the bounding box for the region or something. Yeah, we can work that out. So it's like a region. Yeah. Region min, region max. So that'll be like region index multiplied by g ent region dims. So the size of a region in world space, basically. And then I guess the max would just be like a +1 version of that. So we could probably just do an add. Region min. Cool. So later on we shall use those. So right now we'll comment those out. But right now, we're just going to say we always collide with it and actually solve it later. So this one we'll just do a break, and then we've got to end up constructing a range. So this will then be like, well, we landed in this region. So region index, region index equal iter region index. We've got to flatten it. So where's the screw it? This will be the 3D one. We'll flatten it in a bit. Cool. Yes, this one will actually break. So I guess we go to end. If true, go to end. Rightio, so should be quite straightforward from here. We need to get a flat index of the region. There's a function for that. I think it's called region flat. It'd be in the C file at the top. Right, for a given coordinate, get a flat index. Right, we'll need a region version. Yeah, so we probably want to use Molten code in the future. Region core's a better name. So I'll just call this one. So I have two types of compute shaders in my DSL. Oh no. One that's the usual kind, and one that's specifically for work groups that are less than or equal as big as a wave. Right, why would you have, why, I can't see the reason why you would do that. Well, what's the reason? Is it just to make it, because I find that the rules are kind of different there. Well, you're always putting an if statement at the top to say if I overflow something. I mean, if the work group runs in lockstep, that means there's less synchronization needed. I still don't understand. I still think that, like, whenever I make stuff that's less than a work size of a wave, is typically just to instantiate things. And also when the work group is a wave. My laptop decided to die. Just decided by its very own self that it ran out of battery. Right, so we got that now. We got this one. Should be handy. So your region flat index. So I guess we can call this one a region coord. Better name, innit? Better. Alright, much better there. So we pass in the region coord. Get our flat index. And then let's get the web browser back up on my laptop. I think if you know the work group that runs in lockstep, the synchronization you need, right? Like I imagine writing synchronization primitives that only work on a single wave compute shaders. Oh, you mean, I see. So you're saying if there are multiple waves, you would want to use lock. Right, you want to use LDS memory to transfer stuff and use atomics there and things. But in a single wave, you typically want to use wave intrinsics. And yeah. But you still want to be able to use atomics in single wave things. It's just not the work group. The LDS memory won't necessarily. Yes, the work group memory you won't be using for atomics, but you will still want to use it because it's extra local memory, which is just available. So you might as well use it if the algorithm can benefit from it. Yeah, I don't know why. I don't know. Like, when you have this different compute shader, are you looking at restricting certain things or offering some kind of nicer syntax or something? I don't quite get it. Offering the guarantee, right? Yeah, I still don't understand though. But what will you do with that guarantee? They could check if the shader is running in a single wave. Like people who all the types like mutex-ish things. Right, like a spinning one. Generate the same code. Maybe, I guess. I don't know. Yeah, I'm not sure how much of a benefit would be. Just the compute shader is just fine, I think. Because when you do like, whenever I do stuff in compute shaders, the more in line it is, the better typically. Whenever you start having functions everywhere, you just lose it. Right. Yeah, but it's not worth restricting people to things. Um, right, so you get this flat index thing, and then you should be able to work everything else out. So your entity range, struggling to type there for some reason. Ent range, archetype start index count. So the archetype is going to actually be this take one, unfortunately. So that sucks. Ent range or ent archetype. Cool. Then we need to get the start index. So entity base ent index is one of these. Right, so how many regions? How many regions are there? Sorry, how many entities are there per region? Then we can skip. We can skip over. We can work out the offset into the region that we're looking at. By doing something like this. Region flat index times by the number of entities per region, and I guess it's the base index. So in goes the archetype, in goes the base ent index, then the count. So the count comes from a different array, which would be in the. Got to go over the pools. So it'd be g ent dot archetype pools, index with archetype, get the header, look in the header. There'll be an array. I forget this array's name. This one. So it's not the next frame one, because next frame is one that when you create an entity uses, and then they get copied over. But what you want to use. Oh, I just realized we didn't do the deferred deletion properly. We just removed it from the record. We didn't remove it from the port. Shoot. We didn't remove it in the actual the archetype pools, so we need to correct that. Whoopsie. We'll do that after this. Shouldn't be too bad. Right, so you get the number of entities within that region. So that'll be region flat index. Cool. And this gets you the number of entities in that region. Like that. So that should be the basic logic for doing the iteration, or at least going to the next one. We've still got to instantiate some things. But yeah, it's getting close. Right, catch you later, Mr. Devastated. Good to see you. Thank you for coming by. Okay, think about something like do in one thread, share with all the others when done function. Yep. Like a read lane. That would be implemented differently in a shader with single wave, no? Um, yeah, then you would. Yeah, but then if you want to broadcast or read that lane across all the different waves, it would be. You'd have to, within the groups, you have to transfer it to LDS memory and then read it back. And are you going to try and automate that in your DSL, or are they going to have to do that? What are you getting from the iteration being that way instead of nested loops? So we're still using loops. This is just the condition function that runs. So let's quickly go back to the example. So basically there is still nested loops. We go over every single archetype and then we go over every single region which has entities. Right, that's another thing we need to do. Yeah, every region which has entities. And then we go over all of the entities within that region. So these will all be contiguous in memory. So it's a way of iterating over the entities that are nearby and going over all contiguous data where possible. So yeah, we are doing nested for loops. It's just where the data is a little bit more complicated than just doing a couple of for loops. So we have to use these while loops and have a kind of iterator, basically. So that's something as well, is like if the region, so you've flattened it. So you found this region, and then you realize, hang on a minute. If ent count equals 0, you might as well go back to the beginning again. Good old go-tos. This is the way. You might as well go back to the beginning again because yeah, you want to go back around and keep going. Yeah, then you can always turn 0 there if there's a problem. Right, that should be good enough. Want to empower the user to be able to do in one thread higher order function in the fastest possible way. If the person knows whether they're going to be using Wave or not, it's great information, I think. Right. Okay. Fair play. Yeah. I don't know. I would just write the code in line. Yeah, I'll just write it all in line. Specific per shader. Jobs again. Or just have a function that's called like a macro that just does it. And it's specifically designed for that thing. I don't know why it needs to be. There has to be a thing that's known that it's a single wave or not. It just seems like you'd have a function for one which works in a single wave. And you just call it. It sounds like you can add mystery overhead if you don't know the context. Basically. It just seems like type inference where things are just hidden for like no good reason really. So Call to undeclared function. Right, this is all good. This is all good. So let's go back to that deferred thing. I think we did mess it up. So these should really go. These should really move into the implementation somewhere. And I realized I could implement it without Codegen. Pretty good. I thought I would have needed Codegen to implement these. So we're gonna go ahead and actually move them over to the entity. Let's do that. Let's grab them. That's pretty crap, isn't it? Right, let's v that. All right. Yeah, so I want to like go to entity.c. We'll find iterator somewhere. We don't have it, so we'll just plop it in somewhere. Plop it in here. Grab that. We're still missing a couple more iterator functions, so we'll quickly just grab. Well, we'll come back and do those in a bit. This should be after the include, I just realized. Did it again. After the include, drop. So that looks all right. Okay, so let's go back to that. When you start the frame, we defer delete the entities, but we've only removed them from the record pool. We didn't actually go around and remove them from the actual archetype pools. So we need to be able to swap remove the... Yeah, so we need to go over every archetype, every... No. You have the archetype in here. So we should be able to do a get. True, but the function could reject compilation if it runs in a multi-wave compute shader. It doesn't need to go do all the automagic performance and path. Anyway, see this where it goes. Fair play. That's cool. Yeah, maybe. Maybe there could be some benefits. Ent record. So we get the record. There'll be a reference in there that we want. So maybe I just do ref and then like that, okay? So we can get the archetype from here, and then we want to go and swap remove this element with the one at the back, which is quite involved because it's got to do every single property. So it probably involves a bit of Codegen, actually. So we need to somehow, because the Codegen way would be the best, I think. Man, moving these entities around isn't going to be good. But there shouldn't be many, hopefully. Yeah, so we need to be able to... Yes, another thing that'll be missing is deleting the movement API as well. Let me write that down. Oh, I've already written it down. When the coordinate changes, we need to move the entity to another region. Yes, that's something we still need to do. So you need to switch on the archetype and then select the correct function. Now we don't have, so we might as well make it a function pointer, and then we'll, it should just be a, then we won't have to codegen it. So we should be able to then do something like gent dot archetype archetype ent remove functions, and then we can use entref archetype with the reference, and then we'll call into the function pointer, and we'll pass in the reference, but we'll pass in just the entity ID index into there, and then we should start calling to that function, which we've got a codegen. Then we should be able to basically take the one at the back and move it on top of this one. Yep. For every property. Yeah, that should be all right. So when we move from one region to another, so say if this guy, he ends up moving from this region to that region, we're going to have to do a similar sort of operation where we remove it from this one, and then we move them to the next one. So I wonder if we have another sort of deferred move operation that probably works using a very similar type of API, I'm not sure. But yeah, that's something we need to do next time. So I guess let's write a list down. Write a list. So we need to actually write those deferred, or those sort of codegen, those archetype delete or entity remove functions. That's specific for each archetype. We also need to do the movement thing and the initialization code. Initialize. So what to do? Entity system init. We've also got to do the rest of the iterator, which is just instantiating the iterator, I think. And then that's it. So we should be able to get this done next stream and basically try and test this thing out, right? Get it plugged in. Should be quite nice. There is the game tech plan that we've been doing. So I said I'll do 6 streams on this one. What stream is this one? All right, we're already on part 5, which is basically the 6th stream because we spent 1 stream planning. But then I actually spent more streams planning. So we're kind of a bit behind on the plan already, but that's okay. Doesn't matter too much. So we'll probably be, to test this thing out, I think from the Jobify games section, we're going to move this forward. Produce the render data from game logic. So we're actually going to plug it into the rendering system and have, we need to test the regions. So we'll see the regions in a debug render fashion. And we'll actually have entities that move around from region to region and just see how it works. I think in part where you increment XYZ by 1 for each iteration, you can increase it by the bounding box dimensions instead for less collision checks. interesting. Let's take a peek at that. So I think you might be misunderstanding how it works. Let me just double check. Yeah, so this is the region, the coordinate of the region. Yep. Yep. So, yeah. So we've got the coordinate. So when I say a region coordinate, I'm talking about the whole region itself, right? Not the world space coordinate. So when I'm doing this iteration syntax, I'm skipping over the regions like that. Yep. Whereas not the player coordinate. But yeah. So yeah, I guess slight change of plan with the game tech plan. This has taken a bit longer, but that's cool. Doesn't matter. It's just an estimate, really. But we're going to be moving this. I think I had it back here initially, then I moved it forward. So I think we are going to move this now. This is going to get moved back to doing it here. So we can produce some render data, actually see it all and test it out. Because if not, we would just be moving on and be like, not really celebrate the fact that we've actually built this entity system. So that'd be pretty cool. Shouldn't be too much work to do that. So yeah, next stream, finish off the generator and start on this thing. So that'll be on Tuesday, 7:30 p.m. GMT +1, same time on Thursday, and then 4 hours ago for Sunday. I can share some links. If you're interested in seeing the game tech plan in more detail, there is a video on that one over there. And yeah, there's a Discord if you want to come hang out in the meantime and chat about game development. But yeah, there's also a VOD channel. Past streams live there. Right, I guess everyone have a good bank holiday if you're in the UK. Have a good start to the work week if not. And I'll see you all on Tuesday. Let's rate this guy. Usually doing some pretty cool stuff. Right, see you later guys. Much love. Bye bye.